So here we go. Let's get through this. And like I said, I will not give you homework. So if you are remembering anything, we were in section 4 before we started my trip and the testing. So 4, I told you, was going to be a really, really long section. They have a lot of stuff to cover in section 4. So part 1 was solving quadratic equations using square roots where you got a real number answer. And then part 2 was solving quadratic equations using square roots, but you got an imaginary solution. So right before testing started, I introduced you guys to an imaginary number I, and then showed you how you will be getting imaginary solutions to some of your quadratic equations. That's literally where we left off. And then we were also simplifying square roots and all that good fun stuff. And then there's still a third part to section 4, but I'm going to have to wait and come back to that in a little bit. I'm talking like maybe a couple weeks. But either way, so we are solving quadratics. So I wrote a list of some important things that I want you guys to remember, and then we'll go over the solving again. So just remember, these are quadratic equations. We are no longer working with linear equations. These are degree 2 equations that can be written in the form y equals ax squared plus bx plus c. When you solve a degree 2 quadratic equation, there will be 2 solutions to it, right? The degree of the equation should tell you how many answers you get. The solutions to a quadratic equation, now we know those solutions can either be real number solutions or they can be imaginary number solutions. So now we have imaginary numbers at our disposal. So you were introduced to the imaginary number I. I is the number whose square is -1. Now we know no real number, when you square it, should end up negative. But we needed a way to take the square root of a negative number and still be able to move through the problem. So a long, long time ago, mathematicians created the imaginary number I. And I is the number whose square is equal to -1. So you have to remember that piece of information. And then I showed you, well, if you take the square root of both sides, then you would say I himself is equal to the square root of -1. And those are the 2 pieces of information that you have to memorize about I. You have to know that I squared is -1 and that I himself is the square root of -1. But guys, it's kind of weird. I represents this imaginary number, right? But his value is very, very real. So if you're ever doing a math problem and there's an I squared, that's -1. You're going to take I squared out and you're going to put -1 in its place. There's no reason to ever leave I squared in the problem. However, we don't want the square root of -1 in our answer. So we'll put I in its place. So I stays in your answer. I squared does not. Go ahead, Darian. Yeah, thank you. All right. And then the last thing I wanted to remind you of is, since we are solving using square roots, remember, you can only solve a quadratic equation using square roots if there's no bx term. There can be an ax squared and there can be a c, but there can be no x term. If there is an x term, then you can't solve by square roots. You either have to try to factor it, or you're going to have to solve by the quadratic formula, which is the 3rd way I'll show you starting Monday. All right? All right, let's do it. Let's practice, and then we'll be done. So I broke it up into 3 reviews. The first review, part 1, is going to review when you solve a quadratic equation using square roots and you get real number solutions, okay? All right, so guys, if we had to solve this problem for x, right, using square roots, you have to get whoever is being squared completely by itself on one side of the equal sign. So in this problem, x is being squared. Our job is to get it alone. So you could either distribute the -3 to get rid of the parentheses and start getting everything away from x squared. Or I tried to show you another approach, which said you could leave that, move the 1 away first by doing what? How do you get 1 to go to the other side? Minus it, opposite operations. Then you are left with -3 times the quantity x squared minus 2 equals -18. And then again, instead of distributing and timesing everything by -3, what's another way you can make -3 go away? You could divide it right now. You could divide it away and save yourself the distribution. You're not wrong if you distribute. You can still do that and get to the same point we get to. All right, so now you're going to be left with x squared minus 2 equals 6. Beautiful. Okay, so guys, we're almost there. X is squared. We need to get x squared alone. How do you get -2 to the other side? Plus. All right, and then we're finally left with the statement that says x squared equals 8. So what number, when you square it, do you get 8? That's going to be the answer to this problem. So to find that out, I now have to unsquare x squared. How do you unsquare something in math? Square root both sides. So the square root cancels out the square, and it leaves you with just x. Now, guys, these are quadratic degree 2 equations. The minute you take the square root of both sides and you unsquare something squared, how many answers should you be creating? 2, the plus or the minus version. So plus or minus, and now we have to tackle the square root of 8. Can you take the square root of 8 and get a whole number? No. Maybe the square root of 8 is our answer then. But then you have to ask yourself, can I simplify? Is there a number that you can take the square root of that divides evenly into 8? 4. So we're going to I just take them off to the side. Take the square root of 8 off to the side, and we're going to break it up into the square root of who? 4 times the square root of who's left over? 2. It's okay. And then who is the square root of 4? 2. And then the square root of 2 stays as our simplified square root. So now our final answer, x can be positive or negative 2 times the square root of 2. And Delta Math will let you leave that as your answer. They give you a plus or minus sign. Or you can break it up into 2 separate answers. X is the answer when positive 2 is times the square root of 2, and then negative 2 times the square root of 2. And guys, they're just ugly decimals. Go ahead, Darian.
I always do this thing where I have a 2, 2. I always have like a radical in front of the first one.
This one?
Yeah.
Yeah, a lot, Darian, you're not alone. A lot of students, when they take the square root of 4, they write the square root of 2. But just know, if this is a number whose square root you can take, then he's free. He's no longer stuck under a square root, okay? And that's why we chose him. We're trying to break things out. Go ahead, Jake.
Would it be wrong if you put square, like plus or minus the square root of 2 and then the 2?
No, it's just we don't tend to write it like that. Because then it gets mixed up like, wait, who's under the square root and who's not? All right, so now guys, just so you have perspective, these are real numbers. They're just ugly, irrational decimals that never end and never repeat. If you take 2 and you times it with the square root of 2, it's 2.828427125, and it just keeps on going. So instead of you having to round it to 2.8, I don't want you to round. It's not accurate. We leave it as the square root. Again, negative 2 times the square root of 2, it's negative 2.828. Well, I don't want you to write that. It does have a decimal equivalent, but we don't want to write that. You don't want to round your answers. All right, but that's all they are. They're just ugly decimals, okay? All right, let's try it again. So if you remember, sometimes it wasn't just x who was being squared, it was a quantity. It was an entire parenthesis that was being squared. And if that's the case, your job is to get that entire quantity, that entire parenthesis alone. So when you do these problems, you do not have the option of distributing that 4, because PEMDAS says that you would square something before you multiply. So you do not distribute here to get rid of those parentheses. So since we can't distribute, let's just start moving things away. So who are you going to move away first, the 4 or the negative 2? The negative 2. Add it. Then we're going to get 4 times the quantity x plus 3 squared equals 28. Now, since you cannot distribute the 4, instead of multiplying by 4, how do we cancel the 4 out? Divide it away. And then we are left with the quantity x plus 3 squared equals 7. So guys, you did it. You got what is being squared alone. Now how do you unsquare it? Okay.
Isn't that the same thing as the first problem?
No, because here the square was only on x. Here the square is on this entire quantity x plus 3. Here only x is being squared. Here it's x plus 3 that's being squared. Does that make sense?
Yeah.
Okay. So now how do I unsquare it? Square root it, both sides. So now the square root and the square cancel, and you're left with x plus 3. And it equals, guys, the minute you take the square root of both sides, how many answers are you going to get? Plus or minus. And now, can you take the square root of 7? Does he simplify? Great, let's work for us. Just leave it as the square root of 7. It's a very ugly decimal. It's probably like 2.8 something that never ends and never repeats. And I don't want to have to write that number down and round it. So we leave it as the square root of 7. But now here's the problem. when you have a quantity that is being squared, after you take the square root, you're not done. You still don't have x alone. So what do I still have to do to get x by itself? -3. And excuse my language, but do you guys remember where I asked you to shove it? Where?
Shove it
In
the first.
front of the plus or minus sign. So now it'll say x is equal to -3 plus or minus the square root of 7, which, guys, those are two very real numbers. It's just they're very ugly numbers. They are irrational numbers. They are decimals that never end and never repeat. But again, if you asked your calculator, one answer is when you take -3 and you add the square root of 7, which is, oop, I missed the button, hold on.
So
It's about -0.35. But again, that's a rounded estimated answer. And then the second answer would be -3 subtract the square root of 7, which is about -5.65. But that's rounded. It will never truly make that equation true because it is an estimated rounded answer. So I would much rather leave your answer in its exact form. Go ahead, Dan, any question? All right, and again, at the end of the day, these numbers represent the x-intercepts of its parabola. That means that this parabola, if you graphed it, would cross over the x-axis at 2.8 and -2.8. A was negative, so it would open down. It would look something like that. Those numbers that you just solved for tell you where it's going to cross over the x-axis at. All right, same thing over here. His parabola, if you graphed it, would definitely cross over the x-axis at about -0.35 and about -5.6. And since A was positive, it would open up. You know it looks something like that. That's what those numbers represent. They are his x-intercepts. All right, do you guys remember doing this? Because this was like right before my trip.
No.
That's what we did first. Which one? Yeah. All right, now, well, I did do it before the test. All right, now this is part 2. Now we're going to do the exact same thing. We're going to solve again using the square roots, except now we're going to get imaginary solutions. This is literally what we did right before the test. All right, so if we look at this, hey guys, this one has a typo. I just need you to fix it really quick.
Miss Hardy, you don't have to say excuse me when you say shove it.
I do feel like my mother would be so mad at me, Jake.
I say shove it.
Yes, but I say it on purpose. I'm hoping that it gets you to remember where to put it.
Yeah.
All right. So this should be a +2. I apologize. That's a typo on my part. Make that a +2 in front of this problem, please. Okay, here we go. So guys, same thing. They've asked us to solve this quadratic equation using square roots. I don't see a bx term, so I know I can do it. So x is being squared, so 2 and 5 gotta go. Who goes first? 5. So we'll minus the 5. 2x squared equals -40. Now remember, only x is being squared, so 2 can't stay. You do not want 2 here when you go to square root. You can't take the square root of 2. So how do I get 2 away? Divide it. And now we'll have x squared equals -20. Well, that's a red flag. Something squared ends up negative. There's no real number in this world that when you square it, it should end up negative. So that's our first sign that we should not be getting a real number to this problem. But we're going to push past it and keep solving. How do I unsquare x squared? Take the square root of both sides. The square and the square root cancel. You're left with just x. The minute you take the square root of both sides, how many answers are you going to get? Plus or minus. We're going to get the positive and the negative version. And now you have to take the square root of -20 off to the side. There is no real number that when I square it, I'll get -20. So there's no way the answer to this problem is real. But we know how to fix it now. We know how to show how the answer is going to be imaginary. If you remember, the first thing I told you to do is factor out the square root of -1, because -1 can factor out of every number in this entire world. And then the leftover will be the square root of +20. Much, much better. We want the positive square root, not the negative square root. So now, who does the square root of -1 represent? So now we can put I in his place, and he's telling us that the answer to this problem is definitely imaginary. But we would rather I be in our answer than the square root of a negative number. All right, now we tackle the square root of 20. Either he will stay the square root of 20, or we will simplify it. We know we can't take the square root of 20, but is there a number that you can take the square root of that divides evenly into 20? 4. So we're going to break it up into the square root of 4 times the square root of who's left over? 5. I is literally just hanging out, waiting to be multiplied with anything that breaks free from a square root. So what is the square root of 4? 2, and then the square root of 5 stays. He is a simplified square root. So now on the outside, what is I times 2? 2i times the square root of 5. So that's what the square root of -20 is equivalent to. It's 2 times I times the square root of 5. So now throw that in as your answer. It is plus or minus 2 times I times the square root of 5. And you can literally type that into Delta Math and it'll say you're right. Or you can say one answer is positive 2 times I times the square root of 5. And your second answer is -2 times I times the square root of 5. So guys, what's up?
Why would you want to write?
Just in case you wanted to separate them and see two separate answers. It's just up to you. Just as long as you know there are two answers written there. All right, now, guys, at the end of the day, what does that mean? It means that if these are the x values that make his equation true, they're not real. They're not going to be a real x value that you could find anywhere on a real coordinate plane. So he does not have any real x values that could be his x-intercepts. So it's just telling you that his parabola, A was positive, is somewhere entirely above the x-axis. He never touches the x-axis. He does not have any real x-intercepts. That's what it's telling you. And guys, if you're thinking about an x value that would make this equation true, there's no real number you could plug in for x, square it, times it by 2, add 5 to it, and it would end up equaling -35. The only numbers that you could plug in for x to make this equation true are imaginary ones. I'm telling you right now, if you plug this number in for x and square it and times it by 2, it will equal -35. It will make the problem true. It's just unfortunate that it's not a real number that makes it true. So it's not useful for us on these graphs, all right? But that's all it means. Those are his solutions. All right, do you guys remember doing this right before the test, kind of? Yeah? Yes? A little bit? All right, sadly. All right, let's do one more like this, except let's try one where it's not x2 squared, it's that quantity that is being squared. All right. So again, since it's the whole quantity being squared, you are never going to have the option of distributing that negative to get rid of these parentheses, because PEMDAS says we would square before we multiply. So if we want to get this by itself, what is being squared, you got to get the -1 and the -9 away. Who goes first? Add the 9 away. He's not attached. It's got nothing to do with it. So now we have -1 times the quantity x minus 7 squared equals 45. You are not allowed to distribute that -1 in. You'd have to square first. So since I can't distribute and multiply the -1 in, how could I cancel out and make it go away? Divide by -1. Divide it out. All right, and that leaves us with x minus 7, the whole quantity squared, equals -45. All right, we did it. We got what is being squared alone. So now how do I unsquare it? Square root both sides. All right, so the square and the square root will cancel. You're left with x minus 7. But guys, the minute you take the square root of both sides, how many answers are you going to get? The positive and the negative version of that square root. Well, guys, at the very least, take the square root of -45 off to the side. Who should you definitely factor out first? The square root of -1, and then the square root of who is left over? 45. Who is the square root of -1 representing? I, and that's saying that our answer is definitely imaginary. And now we tackle the square root of 45. Either we can take his square root, we can simplify him, or relieve it. Can you take the square root of 45? No. But is there a number you can take the square root of that divides evenly? Who is it? 9. So we'll break them up into the square root of 9 times the square root of who's left over? 5. And then it will be I times who is the square root of 9? 3. He's free. And then the square root of 5 stays as our simplified square root. So now on the outside, who is I times 3? 3 times I times the square root of 5. And that's what you're going to put in the problem. So plus or minus 3 times I times the square root of 5. But again, because this was one of those quantity squareds, you're actually not done. What do you still have to do to get x alone? Add 7 and then shove it in front of the plus or minus sign. So now x will be equal to 7 plus or minus 3 times I times the square root of 5. So again, one answer is 7 plus 3 times I to the square root of 5. And then the second answer is 7 minus 3 times I to the square root of 5. And again, at the end of the day, it's just telling you that there is no real x value that makes this equation true. So he will not have any x-intercepts. The only numbers that satisfy that equation are imaginary ones. All right? All right, let me stop there. That's how we get the square roots. Do you guys remember doing that? No?
I was so happy. I thought I had it.
Well, that's the easy part. You just gotta shove them over.
I need to do that.
All right, now, just because I had the chance, anytime I can in the future, I think I'm going to do this. Because we have some time left, I want to bring back factoring. We have to keep factoring fresh. So review part 3 on the back.
Miss Hardy, you know Albert Einstein said that education isn't learning stuff, it's thinking.
Yeah, well, start thinking, Jake. If you want me to stop guiding you, I'll let you think about this all on your own and let you take the quizzes and tests. All right.
Like, we could, like, think about how to cheat on the test.
Yeah. Don't you want a doctor who, like, actually learned his medical stuff and didn't cheat his way through school? I fear for what my kids are going to have to see in the future. Will any doctor have actually learned his medical school? Or will you have just used Mathway?
Yeah, think about it. Your grandkids are gonna.
They're doomed. Yeah. All right, here we go. This just get this one done. I told you I won't give you homework. Apparently I spelled woohoo wrong because I thought it's WOO. Yeah, I know. Years of text messaging. I have no idea. Woohoo. I thought that's how you spell woohoo. Anyway, I'm a math teacher. I don't have to spell things right. Here we go. So let's do 3 more and then we're done. So guys, here's the problem though. For 2 weeks now, we have been solving quadratics by square roots. So when you're solving a quadratic by square roots, your whole goal is to get whatever's being squared alone. So you're constantly moving things away from what's being squared. But before, when we first learned how to solve a quadratic factoring, you had to get everything on one side set equal to who? So you got to switch gears a little bit now. Now we don't want to get x squared alone. If we want to solve something by factoring, we want it all on one side set equal to 0. So is that already done for us in problem 5? Okay. So everything's on one side set equal to 0. I see an ax squared, I see a bx, and it looks like there's no c here. That's fine. What are you always supposed to look for first when you go to factor anything? A GCF. What does a 2x squared and a 5x have in common? An x. Take it out. So now we're going to say x comes out. I'm going to times it with what to get me back to that original expression? 2x. 2x. X times 2x. And now x times what gets you back to negative 5x? Negative 5. All right, close it, and it still equals 0. Normally, after you take a GCF out, you're supposed to factor your new expression again. But guys, hold the phone. This is not a quadratic expression. This is not a quadratic factor. This is linear. This is degree 1. The highest exponent on a variable is 1. A linear factor should not factor again unless you missed the GCF. But we should be done with factoring right now. I broke it up into pieces that multiply. I broke it up into this piece and this piece. So now look what the problem is saying. It's saying that this factor times this factor should equal 0. Well, guys, the zero product property says that the only way 2 things in math can multiply to 0 is if one of them is who? Somebody's got to be 0. So either this factor has to be 0, so 0 times this equals 0, or this factor has to be 0, so 0 times this equals 0. But it could be either one. So we find out what makes them both equal 0, and those are our 2 answers to this degree 2 quadratic equation. So guys, if you take your first factor x, and you have to find out what's going to make him equal 0, who is it? 0. He needs to be 0. All right, but what if I need 2x minus 5 to become 0? What does x need to be in order for 2 times x minus 5 to become 0? Well, we have to solve this. What are you going to do first? Add 5. And then you're going to divide by 2. So x will be equal to 5 halves, which is 2.5. So those are your two answers to this degree 2 quadratic equation. Do you guys remember doing that? That's one with just a GCF. All right, let's go over here now. Same thing. If I have to solve this by factoring, which in the future we hope we can solve a lot of the quadratics we come in with by factoring. If I want to solve it by factoring, I need everything on what side equal to who? 0. It will never matter if somebody moves everything to the left and somebody else moves everything to the right. It never matters what side you go to. I try to keep the number in front of x squared positive. So when I go to factor, I don't have to worry about taking out any negatives. So because of that, I look at my x squareds. I can either minus 2 to this side or minus 5 to that side. I'd rather minus the 2. So that's what I'm going to choose to do. Not that it matters. All right, so if I minus my 2x squareds to cancel them, I'm going to minus them from the other x squareds because they're like terms. And then if I'm going to minus 2 this way, I have to bring the 8 as well. So then I'll minus 8, and then I'll minus 8 from the other just numbers that he's a like term with. And now he cancels. All right, so now how many x squareds am I left with? 3. I have 3x squared. It looks like negative 7x are the only x's that I have, so he'll stay the same. And then what's positive 2 if I took away 8? Negative 6, and then it equals nothing, which is 0. So we've got everything on one side set equal to 0 in the correct order. So now we're going to factor it, break it up into pieces that multiply. Well, what do we look for first? A GCF. What does a 3x squared, a 7x, and a 6 have in common? 1 doesn't count because it wouldn't change it if I took it out. They don't all have x's, so I can't take an x out. Nothing. They do not have a GCF, so that means we get to go right to our factors. All right, we know that according to the way we FOIL and the way we factor, that whatever we put in the first 2 spots of each parenthesis has to multiply to who? Which is 3x squared. And guys, who are the only numbers in the world that multiply to 3?
3 and 1.
So who's going to get us a 3x squared?
3 and 1.
A 3x and a 1x. Lock them in. They're the only options for the first 2 pieces. Now we know whatever number we put here and whatever number we put here has to multiply to negative 6. And then our rainbows have to multiply and add up to negative 7x's. All right. So you're only allowed to put numbers here that multiply to 6. That leaves 1 and 6, 2 and 3. Anybody care which ones I try first?
2 and 3.
I like 2 and 3. If I try 2 and 3, would it be worth my time to try 3 here?
I lied.
No, they have a GCF. It shouldn't be there. So you should only be trying the 3 here and the 2 there. All right, now, what is 2 times x? 2x. What is 3x times 3? Ooh, could 2 and 9 make negative 7? Let's work the signs. If I have to multiply to a negative 6, then I know the numbers have to be different signs in order to multiply to a negative. So how can I make these different signs add up to negative 7? I would need what kind of 9? Negative, and then a positive. Let's see if that works. If I need a positive 2, then he would have to be positive. If I need a negative 9, he would have to be negative. Let's see if everything's doing its job. 3x times 1x is 3x squared. 2 times negative 3 is negative 6. 2x and negative 9 get me negative 7. You did it. We factored it. All right, so now, we're not done though, because the factors are just getting us to our answers. So by factoring it, look what the problem says. It says this times this has to equal 0. The only way 2 things can multiply to 0 is if somebody was 0. Maybe this factor was our 0, maybe this factor was our 0. So we set them both equal to 0 and we solve for x. So what's it going to take for 3 times x plus 2 to become our 0? I'm going to, what first?
Subtract 6.
Minus 2, and then divide by?
Wait, what did you do?
And minus my 2. And then I'm going to divide by?
3.
And then x will be negative 2/3. That's one of my answers. If x was negative 2/3, this factor would be 0. And then 0 times this would be 0. But maybe he's not our 0. Maybe this one needs to be 0. So what's it going to take in order for x minus 3 to be 0? X would have to be 3. And he's your second answer to this degree 2 quadratic
What
equation.
happened to the regular factoring going through? Like, it was just like you didn't get the fraction. Like,
Oh, well, that was just factoring. Now we're solving by factoring. So when you have to solve, you have to go past the factoring step. All right, I put this one on here on purpose, and it'll be the last one, and then we're done. This one, do you guys see an ax squared term? Do you see a c and a c technically a just number? There's no bx though, right? There's no just x term. So technically, this one could be solved by square roots. But I asked you to try to solve it by factoring, and I did it on purpose. If I have to get everything on one side set equal to 0, how do I get 10 over here? Minus it. And then you're left with this. 4x squared minus 1 equals 0. Guys, every single one of you had this question on the NJGPA yesterday. They asked you to write 4x squared minus 1 as linear factors. You didn't have to solve. This is a solving one, but you had to factor it. So if you had to factor this, first we'd look for a GCF. What does a 4x squared and a 1 have in common? Nothing. So you have to go right to your factors, right to your parentheses. There's two ways to factor this. Either you're going to go through the motions and you're going to say what times what gets me who? 4x squared, maybe 4x, 1x, maybe 2x, 2x. We don't know. There's two options. Whatever number I put here and here has to multiply to who? Anybody know who has to multiply to?
Oh.
Negative 1. And then who do your rainbows have to add up to? Who are your x's here? 0. You could do it like that. Or, does anybody recognize what 4x squared minus 1 is? The difference of two perfect squares. So then you could just use your square roots. So what's the square root of 4x squared? 2x and 2x is who you're going to need in the front. What's the square root of 1? 1 and 1 go in the last two spots. And then what signs do you need to make sure their rainbows add up to 0? And they multiply to negative 1. 1 plus and 1 minus. So everybody should have gotten 2x plus 1 and 2x minus 1 yesterday. Now, this is a solving problem. So if this times this has to equal 0, somebody has to be 0. So what's it going to take for 2x plus 1 to become 0? Minus 1, you'll get 2x equals negative 1, and then divide by 2, so negative 1/2. What's going to take for 2x minus 1 to become our 0? Now you're going to add 1, and then divide by 2, and you get 1/2. So guys, you get plus or minus 1/2. You would have gotten that from your square roots as well. All right, listen. That was a lot, but it was like literally this is what we've been doing before we've been interrupted for the past 2 weeks. So hopefully you feel a little bit more confident when we go into the next section on Monday. All right, no homework. Just relax over the weekend. Enjoy the nice weather.
Is it gonna rain?
Is it?